All right, so now let me introduce you to the quotient rule. The quotient rule. Okay, so we have already established the fact that when we have expressions of the form y is equals to, let's say, a plus b plus c over x, this is a fraction of which we can apply the quotient rule to solve. But without the quotient rule, we can change this into a linear equation by eliminating the fraction, by denoting this as a over x plus b over x plus c over x. And we can easily differentiate. So now the question is, what if we are having expressions of the form y is equals to a plus b divided by a minus b? In this case, applying this concept will be a bit difficult. And so this is where the quotient rule comes in, where you cannot do the simple divisions. We apply the quotient rule in solving expressions of this nature. All right, so let's look at the quotient rule. If you have an equation, say y is equal to u divided by v, where u and v are both, where u and v are both functions of x, and our v is not equal to 0, and our v is not equal to 0. When you have equations where our independent variable is equal to a fraction that cannot be easily simplified, we use the quotient rule. What is the quotient rule? Quotient rule is saying that if you are having such expressions, then our dy over dx is equal to the v multiplying du over dx minus, note the difference between quotient rule and product rule. The formulas look similar. For the quotient rule, it's a division. Division goes with what? Subtraction. So we are going to have, the next one is going to be the u, and the u is multiplying the v over dx, all divided by the square of the v. Hey, take your noise away. All divided by the square of the v. Are you following? So this is another simple formula you can easily memorize. dy over dx is equal to v du over dx minus u dv over dx. Very simple. So let's look at examples. Okay, let's look at examples where we will apply this formula. Examples. Question 1. Differentiate with respect to x. Differentiate with respect to x. Y is equal to 2x plus 3, 2x plus 3 all over x minus 5. We have y to be equal to 1 plus x squared, 1 plus x squared all over 1 all over x minus 1. All right, so let's see how we can use the quotient rule to differentiate these two equations or expressions here. All right. So let's see the first one. Let's look at the first one. So let's look at the solution. With the first question, I, we are given y is equals to 2x plus 3 all divided by x minus 5. 2x plus 3 all divided by x minus 5. And we have been tasked to differentiate this expression. So what do? The first thing that we do is that we equate or we denote the numerator and the denominator by the parameters in the differential equation. So we are going to say let u equals to 2x plus 3 and v to be equals to x minus 5. Now, after this is done, denoting the u by the numerator and the v by the denominator, don't interchange. The u is the numerator because we said y is equal to u over v. So u is equal to the numerator and v is equal to x minus 5, the denominator. After denoting this, after doing this, the next thing we are going to do is to differentiate u with respect to x and v with respect to x. So we are going to have our du over dx to be equal to, when you differentiate 2x, what do we get? 2. And when you differentiate v with respect to x, we are going to have, when you differentiate the x, you get 1. Don't forget the derivative of 3 is a constant, is 0. Derivative of negative 5 is a constant, also 0. So now, after doing this, denoting u to that and v to that and doing the differentiation, then you quote your formula. So I'll say using dy over dx to be equals to v du over dx minus u over dv, u dv over dx, all divided by v squared. So in this case, we are going to have our dy over dx to be equals to v. What is v? V is x minus 5. So we are going to have our x minus 5 bracket close multiplying du over ds. Du over ds is 2. Good. Minus the next one here is u. What is u? U is 2x plus 3 multiplying dv over dx. Dv over dx is 1. And this is all divided by the square of v. V is x minus 5 all raised to the power 2. Don't waste your time or disturb yourself expanding, okay? So now we simplify the denominator. So we are going to have the 2 here multiplying the s, which will give us 2x minus 2 multiplying negative 5, you get 10. Minus this side, 1 times 2s will give us 2x minus 3. But because of this negative affecting everything in the bracket, so we get negative 2s, negative 3. All divided by the square of v, which is x minus 5 all squared. The next thing we are going to do is to simplify by grouping like terms. So straight away, you can see that positive 2x and negative 2s will cancel out. Have you seen that? Positive 2x and negative 2x will cancel out. So we are now going to obtain the expression dy over dx is equals to negative 10 minus 3. Negative 10 minus 3 is negative 13 divided by x minus 5 all to the power what? 2. And this can be written correctly as negative 13 over x minus 5 all squared. Simple as ABC. All squared. Good. This is the quotient rule. Also very simple, just like the product rule. Quotient rule, very simple, just like the quotient, the product rule. Let's go to the second question. Question 2. We were given y to be equals to, what was the question 2? Y to be equal to 1 plus x squared all over x minus 1, all over x minus 1. 1 plus x squared all divided by x minus 1. So in this case, what are we going to do? Let's look at our solution. So if we have this to differentiate, what are we going to do? I am going to denote the numerator by u and the denominator by v. I'm going to equate the numerator. So in this case, what are we going to have? The question was y is equals to 1 plus x squared. Always write a question before you solve it. Divided by x minus 1. Okay? With mathematics, just quote the equation and start solving it. So I will say let u equal to the numerator, which is 1 plus x squared. And v, the denominator, x minus 1. After doing the denotation, the next we are going to do is to differentiate. So I will differentiate u and I will have my du over dx to be equals to, when I differentiate 1, I will get 0. And when I differentiate x squared, I will get 2x. So in this case, I will get 2x. And when I differentiate my v with respect to s, that is the v over the s, I will get 1. When you differentiate s, you get 1. When you differentiate negative 1, you get 0. So the v over the s is 1. Now, after doing the various differentiation, the next thing we are going to do is to quote our formula, which in this case, the y over the s is equal to v du over the x minus u the v over the x, all divided by x squared. So now, the next thing I am going to do is the various substitutions. Sorry, this is a v squared. Good. So the next thing I'm going to do is the various substitutions. So we are going to have our dy over the x to be equal to v. What is v? V is x minus 1 multiplying du over the s. Du over the s is 2x, bracket close, minus u. U in this case is 1 plus x squared multiplying the v over the s, also 1. All divided by v squared. What is v? V is x minus 1 all squared. The next thing I'm going to do is to simplify. So in simplifying this, to make things very simple for you to simplify, let me bring the 2x in front of the s minus 1. So I'll get 2x multiplying x minus 1, bracket close, minus 1 multiplying 1 plus x squared. Then all divided by s minus 1 all squared. Then I will expand the expression. When I expand the expression, 2x times s will give me 2x squared minus 2x minus 1 minus x squared, all divided by s minus 1 all squared. Good. Then the next one is the simplification. Without doing the lightings, I will know that, or you can also know that 2x squared minus x squared will give me x squared. So here I'll have my x squared. Then we have only 1x here, which is negative 2x, so minus 2x minus 1, all divided by s minus 1 all squared. Or s minus 1 all squared. All right, so we have 3 beautiful questions here. Let's apply the quotient rule and solve this question. Very simple. Let's apply the quotient rule and solve this question beautifully. Are you okay? Okay. So let's see how to solve it. Let's take the first one. In the instance of the first one, we are going to have y is equals to 1 minus x squared all over 1 plus s to the power 2. Good. So when you have expressions like this, you go by the quotient rule. What do? You denote the numerator by u and the denominator by v. You create the numerator by u and the denominator by v. So in this case, let me write that. Let u equals to the numerator 1 minus x squared and our v, it won't go there. Let me clean it. Let me shift to this side. So let u equals to 1 minus x squared and v equals to 1 plus s to the power what? 2. After doing this, the next thing we are going to do is to differentiate the u with respect to x and the v with respect to x. So we are going to have du over dx is equals to, okay, when you differentiate 1, you get 0. But when you differentiate x squared, you get negative 2x. And when you differentiate v with respect to x, when you differentiate the 1, you get 1. You get 0. The derivative of a constant is 0. But when you differentiate x squared, you get positive 2x. After the differentiation, the next thing we are going to do is to write our formula. What is the formula? Our formula is saying that the y over the x is equals to what? v du over dx minus u dv over dx, all divided by x squared. Sorry, v squared. I don't know why I always write x squared. All divided by v squared. Good. So now the next thing I'm going to do is the various substitutions. The various substitutions. So I'm going to have my dy over dx is equals to v. What is v? What is v? V is 1 plus x squared multiplying du over dx. Du over dx is negative 2x minus what? U. Where is our u? U is 1 minus x squared multiplying what? dv over dx, that is 2x, all divided by the square of v. What is v? V is 1 plus x squared all squared. Good. And you don't waste time to expand this expression. Are you following? So we are now going to manipulate the numerators. The numerator here. We are going to manipulate the numerator. Then we simplify. Then that will be it. So to make things easier, let me bring this expressions in front. Okay? Those with only one variables. So we are going to have negative 2x multiplying 1 plus x squared minus 2x multiplying 1 minus x squared all over 1 plus x squared all squared. And this is going to give us negative 2x times 1 will give a negative 2x, right? Minus negative 2x times x squared will give us negative 2x to the power 3. We are done with this one. Then here, minus 2x minus or plus, right? Negative 2x times negative. So you get plus 2x to the power what? 3. All divided by 1 plus x squared all squared. Good. So let's see. Straight away, you will see that negative 2x cubed will cancel positive 2x cubed. So finally, what are we going to obtain? We are going to obtain negative 2x minus 2x. You get negative 4x all over 1 plus x all squared, or 1 plus x squared all to the power what? 2. And this is our final answer. This is our final answer. Very simple. Let's go to the B. Let's go to the B. So with the B, we are given y to be equals to 1 plus x all over 1 minus x squared. 1 plus x all over 1 minus x squared to differentiate. And we are also, same as question 1, question 2, we are going to apply the quotient rule. Very simple. We are going to apply the quotient rule. So, what do? Let's write our solution here. So the question is y is equals to 1 plus x divided by 1 minus x squared. So we are going to we are going to denote the numerator and the denominator by u and v respectively. Okay, so say let u equals to 1 plus x and v to be equals to 1 minus x squared. Very simple. After denoting the u to the numerator and v to the denominator, the next thing we are going to do is to differentiate u with respect to x and v with respect to x. So in this case, I'm going to have my du over ds to be equal to what? 1. Because when you differentiate 1 is 0, and when you differentiate x is 1. Then my dv over dx is equal to, when I differentiate this one, is 0. But if I differentiate this x squared, I'll get negative 2x. Good. After doing the differentiation, the next I'm going to do is to quote my formula. So using the y over the x to be equal to v is equal to v du over dx minus u dv over dx all squared, all divided by v squared. Now let me do the substitution. So we are going to have the y over the x to be equals to v. What is v? 1 minus x squared. So 1 minus x squared multiplying what? Du over the s. Du over the s, in this case, 1. Minus u. What is u? U is 1 plus x. Multiplying dv over ds. Dv over ds is negative 2x. Good. All divided by v squared. What is v? V is 1 minus s all squared. All squared. Good. The next I'm going to do is to simplify the numerator. So I'm going to have the y over the x, and this is equals to 1 times 1 is 1 minus 1 times x squared is x squared. Okay? To make things simple, let me rearrange it so that it will look simpler for you. All right. So in the case of the first one, we are just going to have 1 multiplying 1 minus x squared. Okay? Minus, then the negative 2x will come. Negative 2x multiplying 1 plus x, bracket close, all over 1 minus x squared, all squared. Oh. Okay. Let's clean this side. So let's continue. So we will have our dy over dx to be equal to one multiplying 1, right? So we are going to have 1 minus what? X squared, okay? Now let's come here. Here we will have negative to negative. So the whole thing there will change to plus, okay? Plus 2x multiplying what? 1 plus x all over 1 minus x squared all to the power what? 2. So now, very simple now. 1 minus x squared plus 2 times 2x times 1 is 2x plus 2x squared all over 1 minus x squared all squared. So finally, we can manipulate x minus x squared and 2x squared. So we will subtract this from this one. So we are going to have x to the power 2. That is this and this. Then we will have our plus 2x plus what? 1. All over 1 minus x squared all squared. So this is our final answer. So our dy over dx is equals to this. Good. So with this, I think you can even go down. But if you don't want any issue, you can also leave it this way. Because I can also factorize this one. I can factorize this one. Because x squared is the same as s times x. Then 1 is the same as 1 times 1. Plus and plus. Okay. Good. So this, the top here is the same as s plus 1, which is the same as s plus 1 all squared. So you can also put this one here. Okay. So we can say that this is the same as, or the top there is the same as x plus 1 all squared, all divided by 1 minus x squared all squared. This is correct. This is also correct. Very simple. Let's go to the last question. Let's solve the last question. And that will be 8 for quotient rule. Okay. So we are left with the last question here. Okay, so let's see how to solve the last question. This is the last question. So what do? We denote the numerator. Let u to be equal to s squared minus 1 and v to be equal to 2x squared plus 1. All right. So we have our du over dx to be equal to 2x. And dv over dx is equal to what? 4x. Good. After the differentiation is done, the next thing I'm going to do is to quote my quotient rule. And the rule is that dy over dx is equal to v du over dx minus u dv over dx all over v squared. So now let me do the substitution. I'm going to have my v. What is my v? Where is my v? V is here. V is 2x squared plus 1. Multiplying what? Multiplying du over dx, which is 2x. Minus next one, u. U is x squared minus 1. Multiplying what? Multiplying dv over dx. dv over dx is 4x close. All over v squared. All over v squared. Where is the v? V is here. All over 2x squared plus 1 all squared. Now the next thing I'm going to do is to rearrange the numerators. So I'm now going to have this 2x multiplying everything here. So I will have my 2x multiplying 2x squared plus 1, okay, minus 4x multiplying x squared minus 1, all over 2x squared plus 1, all squared. Okay, so in effect, we are going to have our dy over dx, and this is equal to 2x times 2x squared. It will give us 4x to the power 3. 4x to the power 3 plus 2x minus 4x times 4x squared is 4x cubed minus 4x times positive negative 1 will give us plus 4x all over denominator 2x to the power 2 plus 1 all squared. And this is going to give us 4x to the power 3 minus 4x to the power 3 will cancel out. So finally, we are going to have 6x. We are going to have 2x plus 4x all over 2x squared plus 1 all squared. And this is equals to 6x over 2x squared plus 1 all squared. It is subtraction.